Hi friends, today we will see about high power factor converter simulation, and in the last video we have already seen this simulation of the three-phase inverter. Okay, so now let us change this diagram so that we will obtain a high power factor converter. Okay, so here DC supply is given here and three-phase load is given here. And now let us change the supply and load. Okay, so that means here on the right hand side we will give AC supply, and here on the left hand side we will remove this DC supply and we will connect a capacitor and in parallel with the resistive load. Okay, now let us see that diagram. This is the high power factor converter diagram. So on the right hand side, let us these are the three phase supply, and these are the line inductance, and these are the current measurements, and in the left hand side we have connected one capacitor here, and this is the resistive load, and this is the output voltage. Okay, now let us see the parameters. The supply voltage, AC voltage, how much 230 into square root 2 is given. Frequency is 50 Hz. Okay, and for the second one the phase is minus 120, and for the third one the phase is plus 120. Okay, and inductor value is I have taken 4.5 millihenry. So all the inductor values are same, and the currents, I am measuring the currents, and these are IA, IB and IC, and I have used IGBTs here, and the capacitance value I have taken 3300 microfarad, and the resistance I have taken 20. Okay, no matter how much you take this load resistance. Okay, so here I am measuring the output voltage. Okay, the voltage across this load. And now what is the objective of this high power factor converter? So the objective of this high power factor converter is there are two things. First one is to maintain the voltage across this capacitor should be constant. That is the first thing. Okay, and second thing, we should get the voltage, we should get the unity power factor between voltage and current here on the right hand side. Okay, the current flowing into this phase, flowing through this phase, and the voltage, okay, should be in phase. Okay, and the first one is we have to maintain the capacitor voltage constant. These are the two objectives we have to fulfill. Okay, so this high power factor converter is also called as PWM rectifier. Okay, PWM rectifier or high power factor converter, both are same. Okay, so now how to maintain the two things. Okay, here the control logic is there. So we have to fix the some reference voltage. Okay, how much you want to maintain across the capacitor. Okay, so here I have taken 1000 volts, and V0 is the measured voltage. Okay, so V0 is the measured voltage here, and now we have to get the error. Okay, so V reference minus V0, you will get error. That error is passed through the PID controller. Okay, let us see the PID controller. So I have used only PI controller. Okay, so discrete time and p value 0.5 and integral value 10 is given. So here you have to give some sample time 50 power minus 6. Okay, otherwise you will not get output. Okay, so that I have taken, and after that we have to multiply this with the unit template. This is called unit template. That means VAN, that is here the voltage here. Okay, this is VAN, this is VBN, and this is VCN. So I have taken here. Okay, So that VAN means it has magnitude and phase angle. So we have to divide by magnitude, that is 1 by 230 into square root 2. Then we will get only the phase angle. Okay. So that means in practical we have to use a PLL block. Okay. So to get this value, to get this angle, understand? So you have to multiply these two. After multiplying you will get, this is a ISC reference. Okay, that means IS reference. Okay, so now that will be compared with the IA, IB and IC. So here we have taken IA and IB, IC. Okay, so you have to compare that. So IA reference minus IA. So again some error is there. That error is passed through proportional controller. Here only P controller is enough, and I have taken a P controller of 5. Actually PI controller values are random, that is trial and error method I have taken, and here also you have to give sample time 50 e power minus 6. Okay, so then this is a modulating waveform. Okay, so this modulating waveform is compared with this triangular waveform. This is a triangular wave. So this is a comparison. Then we will get the pulses. This is SCA1 and this is SCA11. That means in the first leg. Okay, SCA1 and SCA11. Okay, so similarly the next two legs, the next two phases. So here it is same. Okay, so next we are bringing this here, and it is now for the second phase VBN here and IB here. So for the third phase VCN here and IC here. Okay, so here triangular wave, I have taken the time values 0, 0.5 by f and 1 by f, and output values -1, +1 and -1. Okay, that will repeat. So the same triangular carrier wave I have taken, and this is the circuit diagram. Here for the scope, okay, so the scope here I have taken, so VAN and IA, that means one phase and current through one phase voltage and current flowing through that phase I have taken, and I have given to the multiplexer and given to the scope, and the second one is V0. Okay, that means we have to check whether it is constant or not. Okay, so here 1000 we have given, and so we should get 1000 here. Okay, so now let us run the simulation. So it is running. Okay, it's finished. Now let us see the scope. Yes. Okay, see here. So this yellow one is the voltage VAN, and this pink one is the current. So if you observe here, both are in phase. Okay, and if you see the voltage V0, so it is at 1000. Sorry, yes, exactly, it is 1000. Okay, so you can change the reference voltage V0. That means you want to get some 800 volts. So now let us run again. So we should get 800 volts in the output. Yes, it is tracking 800 volts exactly, and here the voltage and current VAN and IA, so are in phase. You can see the VBN and IB, so you will get same VCN and IC, you will get same unity power factor. Okay, so this is a PWM rectifier or high power factor converter. So you can use this simulation basically in grid connected systems. So there we can maintain the DC bus voltage, so and we can maintain the grid power factor unity, and finally So the the for the grid connected system, so the DC bus capacitor voltage should be root 2 times the this value, root 2 times this grid voltage. Understand? Okay. So this is the simulation. Okay. Thank you very much.